Hello everyone, welcome back. So in this video, we are going to understand what the questions we have and how we are going to solve the problem number 788. It's a very important question because it's very simple. So we'll try to understand how to approach this type of problem. The question is rotated digits. So what we have given array, we have given a number, right? N equal to 10, right? And we need to count how many digits or how many numbers from, let's suppose, 1 to n, right, are, we can say, good numbers, right? Yeah, good rotations, we can say that. Okay, so if you see, we have to return the number of good integers in the range of 1 to n. Okay, this is what the question is saying. That, let me clean it. So what the question is saying, that we have to return the number of good integers in the range of 1 to n. It means we need to count how many numbers from 1 to n are good, right, after the rotations, right? So how the rotation will works, let's try to understand. Okay, it's very simple, so you will understand clearly. Let's suppose that what is the rotation mean here. Okay, basically each digit rotate like this. Let's suppose we have 0, it will rotate to 0. We have 1, it will rotate to 1. 8 will rotate to 8. 2 rotate to 5, and 6 rotate to 9. Means it's a kind of mirror, we can say that. Okay, that is called rotation here. Mirror rotation, we can also say. Okay, but some numbers, let's suppose 3, 4 and 7, are not valid. Okay, these are doesn't have the rotation. So after rotation, you will get these data, right, for this input data. But 3, 4, 7, we don't have the rotation. These are invalid after rotation. Okay, it will not give. Means when you will find 0, 1, 8, 2 and 6, right, it will called good, right? So when it will call good, a number is good if all digits are valid after the rotation. Means if it comes from any of these numbers, so it become valid. The rotated number is different from the original one, right? That is why. So let's suppose that, let me clean it. Okay, let's suppose that we have input n equal to 10 we have. Okay, so is it valid or not? So we know that the valid good numbers, how we will find that? So we know that we have 2, we'll get 5. We have 5, we'll get 2. We have 6, we will get 9. Will 9, we have 6. Like these are the numbers, you will see that, and we'll say these are the valid numbers, right? So we'll say okay, so these are the valid good numbers we have, right? So we'll say okay, the answer is 4. As simple, right? As you can see, we have given here n equal to 10. So we have taken n equal to 10. Now we have find the valid number. So it is saying that there are 4 good numbers in the range 1 to 10. So we have to always do, if n we have given, so we have to start from 1 to n, right? Means 2 onwards. We have to start from where? We have to start from 2 to 10, right? And 2 to 10, these are the valid good numbers. So we got answer 4, right? So these things you have to understand. You cannot include 1 and 10. These are not good numbers, right? Because we have to take, since they are remains unchanged after rotations. But 0, 1, 8 rotate themselves, right? And so we should not keep it with our examples. Okay, means in the valid range, we can say that. So this is the key that we will do the solution of this problem. Okay guys, now think about the intuition, right? So for each number, right, for each number, we will do 2 things. The very first thing is what? We will check every digit, correct? Digit can be anything. It can be 2 digit, right? So number can be any number of digits, right? So we'll check every digit. First of all, we'll check every digit. Then what we will do, we'll track two things. What are the things we will do? So if this is an invalid digit, right, exist, let's say that if it is invalid digits, just we will reject, right? We will reject. If we will find that, okay, at least one digit changes, means this will give you the valid number, valid good numbers, you can say that, correct? This will give you, means it's very important to understand, because see, for any number means we have given n equal to something, okay? Let's suppose 10, in this case 10, right? So we will check every digit, right? And will every digit means what? From 1 to n we'll check. Then we'll track two things, right? Invalid digit exists, reject this. At least one digit changes, means this contains a valid number, right? So how will you approach this problem, right? So as I told you that, give me a second. So we will understand the approach, right? So let's think that how we'll approach this problem, okay? So the very first, for every number, right, we have to go to 1 to n, correct? Then we'll extract the digit. As we have understand, we will extract the digits, right? So we'll check if it contains, right, if it contains 3, 4 or 7, we will not do anything, we'll just say skip it, okay? Then we will say, okay, now check, means first check here, second check if it contains, if digit contains, or if it contains 2, 5, 6 and 9. Then we'll say, okay, if any of these numbers are there, let's suppose any of these numbers, we'll mark this as a change, we can say. So we'll count all the valid one in the third step. What you will do, you will count only valid plus changed. This we will do, and our job will completed, right? What the induction I told you, it's very simple, guys, right? So for every digits, we'll track the two things, the very first invalid digits, and then we'll check at least one digit should be changed. It means the approach saying that we will use 1 to n, for every numbers from 1 to n, right, we will extract the digits. We'll check that the very first, we'll check if digit contains 3, 4 and 7, we'll skip it. Then we'll check if it contains 2, 5, 6 and 9. If any of these contains, we'll mark as a changed, right? And after that, finally we'll count only the valid and the changed digit one, and we'll return the result. Okay, let me show you. So the very first, as I told you, we will take a count, right? And we'll finally return the count, correct? But between that, we know that from 1 to n, right, the very first step is 1 to n. We'll go and we'll check if it is good or not. If it is good, return, just do count plus plus, right, and you will return the count. Now understand, is it how it will be good or not, right? So very first we'll check it is changed or not. Change will take as a false. If it is true, we'll return true, otherwise it will go false. So for all the digit, right, if the number we have given, so we'll take 1 to n digit will be there, because we've taken the for loop. So we'll start from 1 and it will go keep going ahead, right? So what we will do, we'll check the nums, if it is greater than 0, right, the very first will extract a digit, right, and means the single digit we can say, right, we have to check every digit, right, so we'll do that. So check its every digit. If it contains 3, 4, 7, return false. Okay. Otherwise, if it contains 2, 5, 6, and 9, we'll change, we'll mark is a true, and then we'll keep getting by divide by 10. So we will keep excluding one by one digit, right? Means for 12, let's suppose 12, we have checked with 2, means 2 said that it's a true, right? Then what we will go, we'll divide it, then from 12 it will become 1, right? Then it will come again in this loop, right? And is still greater than 0, so we'll say okay, we'll find the only one digit 1, then we'll keep ahead, keep checking this one, right, like that. So you will save somewhere this is changed or not, like that. You will keep checking all the digits, right, and you will return this as a it's rotated or not rotated, right? This is what we need to do, guys. So if you will talk about the what you call uh, the time complexity, guys, right? So as you can see here, right, we will go for all the digits, right? Here we will check all the digits, right, in the while loop, right? And we have we also have a for loop. It will take O of n, but O of n will go with O into n into digit, we can say that, right? So what will happen, it will give you O n log n approximately, and there is no space, so we'll say space is O of 1, the constant variable will have. Okay, okay guys, that's all in this video. Thank you so much. I'll see you in the next one. Bye bye. Please take care and keep supporting ExpertFunda, and keep sharing the video with your friends who are preparing for the FANG and the other preparation. Okay, thank you.